All right, so we are on page 307. We are on the fundamental theorem, the evaluation part. The second part that we talked about yesterday said that if I had a to b f of x dx, this is the same as the antiderivative b minus the antiderivative a. Okay, we talked about this, right, yesterday. This was not yesterday, a couple days ago, all right? So if f is continuous at every point of a to b, then and if f, large f, is any antiderivative of f, then this is what we get. Okay, this is also called the integral evaluation theorem. Okay. FTC part 2 is what I know it as. Okay. So let's go ahead and go to example number 5 and see if we can do this. Example number 5. We have evaluate -1 to 3. And we have x cubed plus 1 d of x. So we have to find this is a small f of x, right? So we have to find the large f of x. What is the large f of x here? It's the antiderivative. What is it? What is the antiderivative of this? What do I take? When I take the derivative, I have to get this. So it'll be 1/4 x to the 4th. That gives us that. And to get 1, what do we need to have? We need to have x, right? So this would be your large f of x. Now I have to go 3, right? So the first one will be 3. And then I'm going to subtract the -1, right? So it's going to be plus -1, right? This is basically the large f of x, large f of 3. This is the large f of -1, right? Let's go ahead and evaluate this. I get 481 plus 3 minus 1/4, because this is just basically 1. The minus 1, but I have a minus there, so I'm just going to go ahead and pull the minus out and go like that. I guess I don't need this anymore, right? So this guy becomes 20 plus 3 and 1, so it's going to be 24, right? 24, everybody see that? So I got 24 there. Area connection. So let's go ahead and do the other one. Example number 6. Example number 6. We find the area of the region between the curve, that and that. And we're doing 4 minus x squared. So we're going from where to where? From 0 to 3, correct? So notice that they said the area between the curve and the x-axis, right? So this is 4, which would make this 2, -2. And we have 3. So going from 0 to 3, right? So since they said area between the curve, we can't just go ahead and blindly take the integral from 0 to 3, because this is positive and this is negative, correct? If we did the integration, area under the curve, right? But since they are asking for the area under the curve, area between the curve and the x-axis, you would take the integration from here to here just as you would normally do, but you would have to flip this one because you don't want to subtract it, right? It's asking for a different thing. If they just blindly asked 0 to 3, 4 minus x squared d of x, that would be something else, right? You would count from here and you would go positive. So you'd be adding positive here and you would add a negative here, right? And then you would get something there. But since it's asking for the area between the curve and the x-axis, it's asking for this guy. Then you have to switch this guy because if you just went from 2 to 3, it would be a negative, right? But so we have to make that negative into a positive. So this is going to be the same as 0 to 2, 4 minus x squared dx. Then we would subtract the minus 1, which is 2 to 3, 4 minus x squared dx. Everybody see, oops. Everybody see the reason behind this negative here, right? Because it was normally a negative area. Now I'm switching that to a positive area, right? Let's go ahead and do this. Antiderivative here would be 4x to get 4 minus 1 cubed x cubed. Now, if I take the derivative of this, I get x squared, right? I have to evaluate this from 0 to 2, and then minus the same antiderivative, but I'm going from 2 to 3, right? Okay. So what I'm going to get over here from 2. I put 2 in, I get 4 times 2 minus 1/3 8, right? And then I'm going to subtract out the 0. But when I put 0 in, what do I get? I get 0 and 0, right? So there's nothing there, so I'm not even going to write that. So this is the first part. The second part is I'm going to negative. If I put 3 in, I get 12 minus 9. 12 minus 9. Subtract the 2 out. When I put 2 in, I get 8. I'm going to like that. Okay. So I get 8 minus 8 over 3 minus 3 here. So that's, never mind. 3 minus 8 is minus 5. So it's going to end up being positive 5. Then I have a negative 8 over 3. 13 minus 16 over 3. Ugh, really? 3 over 39. 23 over 3? Is that the correct answer? Okay. Can you see before I erase this? Just out of curiosity, can you see that this here is the same as if I took the derivative, no, not derivative, integrated that? Does that make sense? I took the absolute value, because that, what does that do to this? This now becomes up like this, right? And that goes away, I'm going to add this to this, right? Are we good there? So you would use this if you're doing FNINT, right? If you're doing it in calculator, you would use this. Right? Okay, that's number 6. Oh, example number 7, you're going to let us do FNINT. Example number 7. Oh, there's a green box there first. Go ahead and read that. The top of page 309. How to find total area analytically. Just what we did, right? We add the absolute values together, right? All right, example number 7. Find the area of the region between the curve that and the x-axis over the interval between -3 and 3. Okay, well, that's what we did, right? So let's see, get your calculators out and see if you can get to do this. -3 to 3, and we are doing what? X cosine 2x dx. And they want the area between the curve and the x-axis again. So you're going to have to do the absolute value here, right? So go ahead and see if we do the FNINT absolute value. X cosine 2x -3 to 3. And that actually shows you how to do there, right? On the bottom green box. FNINT gives you have to put the function in, x, and then a -3 to 3, right? Did everybody able to get the correct answer? Eva?
Yeah.
Luke? Supposed to get 5.43. You got it? Okay, good. Right. That. All right, example number 8 is actually a pretty fun one. So using the graph of f to analyze h of x. So example 8 gives you a graph. It looks like this. 1, 4, 3, 6, and 8. So this is the graph of f of x. The graph of f of x. But the questions that they're asking are asking about h of x, which is what? Which is from 1 to x f of t dt. Okay, so can anybody tell me what h of x is in your own word? What is it in your own words? What is h of x? We're starting from 1, right? Because we're taking the integral of f of t dt. This is f of x. Okay, so we're taking the integral from here, and x is going to go this way, right? So what is this function called? What do we call this function? It's the accumulator function, right? We're accumulating from 1, and we're moving this way, right? That's what h of x is. Okay. A, find h of 1. H of 1. What would h of 1 be? Why would it be 0? Because you're going from 1 to 1, right? 1 to 1, so it's going to be 0, obviously. There's nothing there, right? B, h of 0 is positive or negative? H of 0, so it would be 0 here, right? H of 0 is going to be what? I'm going from here this way. So it's the same as me asking this, right? Right? Isn't it? But if I go from a 0 to 1, the accumulator function y, is that a positive or negative? Positive, right? So since this is positive, then I have a negative here. It's going to be a negative number, right? So it's going to be negative, okay? C, find the value for x, which h of x is the maximum. So where does h of x max out? I'm going from here. I'm adding, right? I'm going accumulator function. I'm going all the way. I'm adding positive, adding positive, adding positive, adding positive, adding positive, till I get to here, right? Once I get to here, I'm going to add negative numbers, correct? So what's my maximum number? When x is equal to 4, right? So h of 4 is going to be my maximum, right? What about the minimum? So it's going to be all the way to get maximum. Then continue to add negative stuff until I get to here, right? So h of 8 would be my minimum, right? E, find the x coordinates of all points of inflection on the graph of this. Okay. Point of inflection. When does the point of inflection happen? What has to happen for the point of inflection to happen? Huh? The second derivative has to be 0, correct? Second derivative. So the second derivative of h has to be 0. In other words, h double prime of x needs to be 0, right? What is h single prime? I'm taking the derivative of this guy, right? What is the derivative of this? This is FTC part 1. In part 1, remember when I took the derivative of this, this becomes f of x, right? It becomes f of x. But now I have to take another derivative, right? H of double prime is going to be equal to f prime of x. So when does f prime of x become 0 here? Everybody see that? Right? Because the slope is 0, 0, 0. Right? Okay. Little bit of kind of curveball at the end here. Oh, we're done.